Oh, hey, we're here. All right, so anyway, I went in. There it is. I wrote it out. And I went in and put it in my calculator. So notice it solved. So let's come back to the front. So solve zx minus 2 equals 2x minus y and zy minus 3 equals 3y minus x, comma, y. And so that's exactly what I had previously. So at least I feel better about my life now. Now, you can complete the square on that, which is I think what I did on the answer key, but you don't have to. So let's write them out here. So that's z squared minus 5z minus 5, z squared minus 5z minus 5. And then what was it on top? I forget. And to 2z minus 9, 2z minus 9. This is one where eigenvalues and eigenvectors probably work better for this one, but whatever. So what a guy can do if you wanted to, you can break this into two pieces. You can do it like this. Just split it like this. In other words, don't try to complete the square. Just do it like this. Or you can complete the square if that makes you happy. If you complete the square, what you'll find is that it's a hyper, come on, dummy. A hyperbolic sine, hyperbolic cosine. So what you can do as well, though, you could just do 5 plus or minus the square root of 25 minus 20 all over 2. So 5 plus or minus the square root of 5 over 2. And so when you do that, those are two numbers there. Let me get my calculator here. So 5 plus the square root of 5 parentheses divided by 2. Whoops. So, oh, you dummy. So 3.61-ish. Okay, and the other one is if you minus, you get 1.3. 0.381. It's actually more like that. Anyway, whatever. What that says to me is this, then. Okay. Okay, so I do actually. Well, that's not true. I can't write like this. I have to actually. I'm going to expand it, and I'll show you what I mean by that. I can't do that because I need to get a constant on top of each one of those guys. And you'll see what I mean by that in a second. So, well, let me back the train up. Suppose I did that. Suppose I rewrote that as. So this is where I think it probably makes more sense to do it with eigenvalues and eigenvectors. But check this out. Suppose I did this. 2z minus 9 divided by. Suppose I wrote it like this. Suppose I wrote it as z plus. Now hold the phone a minute, dadgummit. Okay, just a minute. Something's a little screwy there. I gotta go back and look at my numbers again. Something's not quite kosher there. Oh, my numbers. Where are my numbers? Oh, my numbers were on here. So I'm gonna do this real quick. Hang on. So I'm just gonna do this real quick. Excuse me. Allergies haven't bothered me all day until I sit down and start talking. Equals 0, comma, x. Let's just get the actual values. Here we go. And the hell did I do wrong? Apparently I can't run a calculator, is what I did wrong, you moron. Oh, there you go. So 5.85. Sorry about that. So 5.85. And negative 0.85. All right, so let's pretend those are our things. What that means is that I could rewrite my denominator as this. And then I could do it and expand. Are you with me? Now, I won't do the one I did on the I won't do this one this ugly on the final. It's just not something I would do. I'm not that kind of guy. But what you could do is you could come in here and go 2z minus 9 divide by, and then do z. Oh, I did x. Well, it's supposed to be z's. I'll change them in a minute. Okay. What? Oh, you hippie. Sure. Okay. So these are supposed to be z's. Let's fix that before it freaks me out. All right. Anyway, as I was saying before I was so rudely interrupted. Oh, look, there they are. And so what do you see? You see 0.018 e to the minus 0.85 plus 1.98 e to the 5.85 t, and you're done. That's x. And of course, y would be similar. So you could have done it with hyperbolic sines and cosines, which is what I did, and that's totally fine. And when you did hyperbolic cosine, you would have gotten, well, you would have gotten whatever I had here when if had I done it correctly. How about that? Oh yeah, it's because it should have been a plus right there. That's right. Yeah. So what you would have gotten was you'd have gotten e to the 5/2, and then the hyperbolic cosine, it has to do with its e to the, that's going to be what, 3 root 5 over 2 minus e to the 3 root 5 over 2 t negative whatever. And when you distribute this times this becomes this one, and this times this one. Or when you add those together, you get this guy here. And you're like, whoa, it's the same thing. It is. Obviously, coefficients here, right? This is hyperbolic sine. Sine is the negative one. Cosine is the positive one. Anyway, that's the game. That's how it works. So, hope that helps.